Hi guys, this is O-Level Chemistry, paper 11, November 2015, question 11. The equation shown represents the neutralization of aqueous sodium hydroxide with dilute sulfuric acid. How much sulfuric acid is required to neutralize 100 cm cube of 1 mole per dm cube NaOH? So, the molar ratio of NaOH is to H2SO4 is 2 is to 1, and they've given us the volume and concentration of NaOH. So, we calculate the number of moles of NaOH, which would be 1 mole in 1000 cm cube. So, how many moles would be present in 100 cm cube? So, this would be 100 upon 1000 into 1, giving us a value of 0.1 mole. And since the molar ratio is 2 is to 1, so the moles of sulfuric acid required would be half of 0.1, which would give us a value of 0.05 moles. Now we need to find the option in which 0.05 moles of sulfuric acid are present. So we will calculate the moles in each option given. So in option A, we have 50 cm cube of 2 mole per dm cube sulfuric acid, which means this would be calculated as 50 upon 1000 into 2, which would give us a value of 0.1 moles, which is incorrect. The next would be 100 upon 1000 into 1. 100 is the volume of sulfuric acid, 1000 is the concentration volume, and 1 mole per dm cube, 1 is the mole present in that 1000 cm cube. Therefore, this also gives us a value of 0.1 moles, which makes this option incorrect as well. The third option would be calculated as 25 upon 1000 into 0.5. So this would give us a value of 0.0125, which is not the option that we are looking for. So this gets eliminated as well. And the last one would be 50 upon 1000 into 1, which would give us a value of 0.05 moles. And this is the value that we are looking for. Therefore, the correct option for this question is option D. Question 12. Which change in condition increases the energy of particles in a reaction? Increase in concentration has no effect on the change in energy of the particles in a reaction. Increase in pressure also do not have a change in the energy possessed by the particles in a reaction. Increase in temperature, yes, because temperature is directly proportional to the kinetic energy possessed by the molecule. So if the temperature increases, the kinetic energy possessed by the molecules would increase. This would result in an increase in their energy possessed by all the particles during a reaction. And the last one is presence of a catalyst. A catalyst has no effect on the increase or decrease of energy possessed by the particles in a reaction. Therefore, the correct option for this question is option C. Question 13. Which changes endothermic? The first one is methane burning in oxygen, which means combustion of methane. Combustion is always an exothermic reaction. Next, H gas plus Cl gas gives HCl gas. This is bond making. Bond making gives off energy, so this is also an exothermic reaction. The next one would be H2O gas, which is steam dissociating to give 2 moles of hydrogen gas and 1 mole of oxygen gas in the atomic state. So this is bond breaking, and bond breaking takes in energy, which makes this reaction endothermic. And the last one is a change of state of water to the solid form, which is ice. So this is freezing, and freezing gives off energy, making this process exothermic as well. Therefore, the correct option for this question is option C. Question 14. The enthalpy changes when methane, butane, and octane are burned completely in oxygen are shown below. Which are the enthalpy changes when propane and pentane are burned completely in oxygen. Okay, so methane has a value of minus 890, butane has a value of minus 2877, and octane has a value of minus 5512. Now we need propane and pentane. So propane is just above butane, or rather lesser than butane in magnitude, and pentane would be just a little higher than butane in magnitude. Now methane and propane has a difference of two carbon atoms in it. So the value that we will have would be closer to the value of butane, but lesser than the value of butane, but it would be much higher than the value of methane. So the two options available are minus 2220 and minus 1560. So minus 2220 is closer to butane and minus 1560 is closer to methane, eliminating minus 150. So option C and D have been eliminated. We continue with options A and B. Now, for pentane, the value should be a little greater in magnitude than butane, but much lesser than octane. So the options available are negative 4210 and negative 3530. Now, 4210 is closer to octane than it is to butane, while negative 3530 is closer to butane than it is to octane. And since pentane has just one more CH2 group compared to butane, the value of the enthalpy change would be closer to butane as compared to octane, eliminating option A, making option B the correct option for this question. Question 15. In the ionic solid zinc phosphide, what is the formula of the phosphide ion? Okay, so zinc has a charge of 2 positive and there are 3 zinc ions present. So a total charge of plus 6. We have the phosphide ions which are 2 in number and we don't know the charge on the phosphide ion. So in order to balance this charge, we would have negative x. We are calling the charge of phosphide x into 2. So we have positive 6 and then minus 2x. So plus 6 minus 2x equals 0. So the sum of the charges of the ions present in an ionic compound is equal to 0. So now let's solve this mathematically. This would become plus 6 equals 2x. Then it would be plus 6 divided by 2, giving us a value for x, which would be 3. And since it is a negative ion, phosphide would have a charge of minus 3, making option A the correct option for this question. Question 16. Iron is produced in the blast furnace. Which statement about this process is correct? Carbon is oxidized to carbon dioxide. Yes, carbon has an oxidation state of 0. When it burns in oxygen, it produces carbon dioxide, in which carbon has an oxidation state of plus 4. So this option is correct. Next, carbon monoxide is produced by thermal decomposition of calcium carbonate. No, calcium carbonate does not thermally decompose in the blast furnace. In fact, it reacts with the acidic impurities present to form salt and release carbon dioxide gas. So this statement is incorrect. Hematite is reduced by calcium carbonate. Hematite reacts with carbon monoxide. It is reduced to iron and carbon monoxide gets oxidized to carbon dioxide. So this is incorrect as well. Impurities are removed by the hot air blast. No, they are not removed by the hot air blast. The hot air blast is there to cool the content. So, and obviously provide enough uh, oxygen and the heat for oxidation to occur. So this eliminates all the other options other than carbon is oxidized to carbon dioxide, making option A the correct option for this question. Question 17. The energy profile diagram for a reaction is shown. And since the energy of the products is greater than the energy of the reactants, this is the energy profile diagram for an endothermic reaction. Okay. So which statement is correct? The activation energy of the reactants is H3 minus H1. H3 is the maximum energy state during the progress of a reaction, also known as the transition state. And the activation energy is given by this energy gap. So this energy gap is defined as H3 minus H1, making option A correct. So the next one says the activation energy of the reaction is H3 minus H2. It is incorrect. The third one says delta H is H1 minus H2. The delta H value here would be the energy gap between the reactants and H2, and this would be given by H2 minus H1, not H1 minus H2. So this is incorrect. And the last one says delta H is H1 minus H3. H3 is not even involved in the calculation of delta H, making option A the correct option for this question. Question 18. In which reaction is nitric acid acting as an oxidizing agent? In the first reaction, we have got copper metal having an oxidation state of 0, and in the product, we have copper nitrate having an oxidation state of +2. So copper is undergoing oxidation in this reaction. In the second reaction, we've got copper oxide, in which copper has an oxidation state of +2, and it is converted into copper nitrate. Still, copper has an oxidation state of +2, so no oxidation takes place here. In the third example or the equation, we have sodium carbonate with sodium having an oxidation state of +1. And in the products, we have sodium nitrate, which also has an oxidation state of +1. So no oxidation occurs. In the last equation, NaOH has sodium with an oxidation state of +1, and the product NaNO3 has sodium with an oxidation state of +1. There is no oxidation taking place here. So only in the first equation do we have copper being oxidized to copper 2 positive, which makes nitric acid the oxidizing agent for this reaction. Therefore, option A is the correct option for this question. Question 19. Which occurs during the electrolysis of dilute sulfuric acid? Hydrogen and oxygen are formed in the ratio 2 volumes of oxygen to 1 volume of hydrogen. No, it is formed in the ratio of 2 volumes of hydrogen to 1 volume of oxygen. Hydrogen is formed at the positive electrode. Positive electrode is the anode where oxidation occurs, and oxide ions are oxidized to oxygen. So it is not hydrogen that is formed at the positive electrode, it is oxygen gas. Oxide ions are oxidized to oxygen. Okay. Oxide ions could be oxidized to oxygen, but oxide ions are not soluble. We have hydroxide ions here oxidized to oxygen. Although I said oxide in the first, in the second statement, it was supposed to be the hydroxide ion. So we have hydroxide ion converting to oxygen gas and producing water. So it would be 4OH minus producing H2O and O2 gas, and it gives off 4 electrons, making this an oxidation reaction. So that is why this is supposed to take place at the positive electrode, formation of oxygen. So it is not the oxide ions, it is the hydroxide ions that are oxidized to oxygen. And the last one says the dilute sulfuric acid becomes more concentrated. Yes, because when hydroxide ions are removed in the form of oxygen, so the quantity of water actually decreases. And when the quantity of water decreases, the concentration of the sulfuric acid present increases, because the total quantity of sulfuric acid remains the same while the quantity of water is decreasing. This statement is correct. Therefore, the correct option for this question is option D. Question 20. Methanol is made in industry by a reaction between carbon monoxide and hydrogen, and this is an exothermic reaction. The process is usually carried out at a temperature of 400 degrees Celsius. Which row correctly shows the effect on both the position of the equilibrium and on the rate of reaction of increasing the temperature to above 400? So if the temperature increases, the rate of reaction would increase, because an increase in temperature would result in the reactant molecules gaining kinetic energy and colliding more frequently with each other, resulting in more effective collisions taking place. Therefore, the rate of reaction increases. So, options A and C have been eliminated. We will continue with options B and D. Now, the position of the equilibrium. Since this is an exothermic reaction, an increase in temperature will favor the endothermic side, and the endothermic side is the backward reaction, not the forward reaction. So the position of the equilibrium will move to the left and not to the right. So option B has moves to the left, option D has moves to the right, option D gets eliminated, making option B the correct option for this question.